All right, so welcome, folks. So last week, Thursday, in my absence, I had indicated what you should have done for the class time, and there were two things in particular. You were supposed to watch the Visual Studio recording so that you can configure your systems for Python properly. The tool that we want to use is Visual Studio Code. Just give me 1 second, please. Yes, sorry for the intrusion. So as I was saying, you should have configured your machine to use Visual Studio Code. So what we have been doing so far, and what we'll do for this week as well, is to use the Python notebook that gives us a simplified interface in terms of executing the codes and appreciating the codes. But when we're moving into what I'm going to call real development, then we want to have a more integrated process. And that is what Visual Studio Code Editor will allow us to do. So I'm assuming that at this point, most, if not all, persons have already configured their machines for that. So can you give me some indication as to those who have completed that? No, I'm asking about Visual Studio Code now. So I assume that everybody has configured the Jupyter Notebook already. So now I'm asking specifically for Visual Studio Code based on what I'd asked you to look at in Thursday's class. All right, so it seems as if based on the lack of response, most people have not done that. So that's one thing that is on your agenda to do today and get it out of the way before Thursday's class. All right, Courtney, the rest of the video might not be necessary for you, but for those who find it valuable, then fine. So you use what you need. You read it, you install it.
Yeah,
Yeah.
just install it and install both extensions. I just opened the other folder that we were using before, so I didn't need to create an environment.
Which extension? Explain that.
No man,
Extensions.
after you install the VBS Studio, you have to enable two extension.
Oh, all right. Yeah, because I did set up a Juniper notebook that I've never used before. Because I was wondering why we're not
That
using
was
Visual Studio.
no, that was the one before.
Which one? Yeah, I know, but I was wondering why we weren't using it in the beginning. So, but all right.
No man, he said it was to ease your interface. You understand me? It was just preliminary interface.
All right, so I guess that is out of the way now. So that's one thing that you need to complete before Thursday. The second thing I'd asked you to do was to go through a set of Python content that I had placed on the portal. It's called session one underscore content summary underscore expanded. So may I also get some indication of those who have actually gone through those 20 or so pages? All right. So once again, it seems as if, based on the lack of response, that most persons have not looked at that. Um, I'm just going to say that it's important to go through the material that I'm asking you to go through, especially if I'm unavailable, and that take the time out to reach out and say, go through this. Then it means that I think it's important to go through so that we can have a smoother process as we move through content. Um, that would have allowed us to capture. Yeah, it is some off, but it is not all off. And I would really appreciate if we could move on. It's going to be difficult to move on if the class has not gone through the material, because it means that you're not going to be familiar with the material. So we're really going to have to be starting from scratch. That's my thoughts. And you had the time last week. So in my mind, there's no excuse for not having gone through the material.
Sure. Question.
Yeah, man, I'm listening.
I'm just looking at the schedule and the stuff that we are supposed to go through. Um, I'm wondering because I see that we should be doing like pseudocodes and flowcharts and stuff like that, which I consider like the fundamental to go into the meat of the matter. Um, I just trying to understand how we got here, just starting writing codes, if we're not going to go to the basics as it's said in the schedule.
All right. So in answering, I'm going to ask a question. What is the aim of the course? And anybody can answer. In your estimation, what is the aim of the course? What's the final objective?
Acquiring the basic concept of programming language.
The basics. Alright.
You can give your thoughts. That's Courtney's thought. You can give your thoughts.
That's the intro to programming, so I guess it's an introductory course.
All right. Anybody else?
remember our modules are compressed, so some
Compress, what you mean?
if you're ever supposed to do full programming at its full level, it doesn't start or stops here.
Yeah, that's kind of what I signed up for, but yeah, my mistake, I guess.
All right. So, as was rightly stated, the aim of the module is to get you familiarized with programming. So, at the end of the day, you should be able to write programs. So, let me backtrack now. A flowchart is not a program. Pseudocode is not a program. There are stepping stones that can assist you
Design
in,
concept.
in understanding the concepts which you are being exposed to in programming. So they are stepping stones. That's not my primary focus. My primary focus is to get you to program. So, quick question to the class based on what I have covered already. Do you understand the content so that you can write simple programs using the construct that we have looked at?
Most definitely, sir.
All right, so that's one person's perspective. What about the others? This is the time you can talk, of course, especially who raise the questions or the concern.
I would just need to practice more since I'm rusty, but yeah, I'm pretty sure I'll catch on.
All right, cool.
It's not anything hard, really.
All right. What raise the concern?
So for me, I do understand, but my concern was that just looking at the schedule, and I know that when it comes to the time for tests and stuff like that, my concern was that we'll be going back to those material according to the schedule that we haven't touched. So, I mean, I understand what we are doing so far, following, but just a little concern.
So the concern is I will test you on things that we have not covered.
But I saw that it was included in the program, so I was just wondering if you were going to do it or.
All right. So if that is your concern, I will not test you on things that I have not exposed you to, if that is the concern. Having said that, did you go through the pages that I asked you to go through?
So I did. I'm at page 20. Just
Mhm.
a little. I think 3 more pages to go to complete the first one.
All right. Excellent. Excellent. Now, once you understand that as the framework, you will realize that when you look at maybe like 2 and 2, then there's some elements of flowchart in there that I will now go through and kind of conceptualize some of the codes that you're actually seeing inside of this first node set. All right, so I don't think anybody should be concerned. One, I won't test you on things that I have not exposed you to. And two, the aim of the course is that when you finish, you should feel comfortable writing programs. And if at the end we have achieved that outcome, then I believe that we have fulfilled the mandate of the course. Nobody, when you go out there, not going to ask you to write pseudocode or draft flowchart. Those are stepping stones. Everybody going to ask you to write codes, though. All
So
right?
one more question, sir.
Sure.
And maybe this is not relevant, but we have literally seen people losing their jobs to AI. So the whole writing code, I'm just having second thoughts, but not to give up, but just to think about, is this, like what the future will look like, to be honest. I don't know, just get your thoughts on it, not just in Jamaica, but worldwide.
Well, I can only tell you my experience with the tools. Um, do they accelerate the development process? Yes, they do. However, the challenge with large language models is that they hallucinate. And because it's a prediction machine, pretty much. If it is trained with bad data, then you get inconsistent, or may I even say bad results. If you do not understand the fundamentals of programming, when you get these pieces of code out of it, then you don't know where it is going wrong. You don't know how to fix it, how to tweak it. So yes, there are persons out there who are saying that vibe coding, that is what they call it, is here to stay. But I am willing to bet that most of the applications that are still going into production have some human is providing oversight. Will they need as many programmers? Maybe not. But will they need programmers? Absolutely. That is my thought on the matter. And I could be wrong.
You need AI programmers.
Well, apart from AI programmers, I'm saying that we need programmers. There are applications which are being used to run organizations. These applications need to be maintained. If it is a critical system, I am sure I'm willing to put my top. Well, I do have no money. But if I had money, like how Courtney have money, I would be willing to bet all of that money that for critical systems, there's always going to be human oversight necessary to look into these systems, maintain these systems, and ensure that these systems are operating like how the organization wants it to operate.
Especially database.
Yeah. So that's not going to be left up to AI and AI alone. That's my thinking.
All right, sir. I mean, I guess I need to stop looking at headlines. It doesn't look.
They kind of drop off.
I was saying, I guess I need to stop looking at headlines because the very companies like I want to work at, Microsoft and Google, are putting people through the door. But I will persist, I guess. I'll persevere.
All right, my boss.
They will
Uh,
take your ideas, but they're not going to pay you.
this is nothing new, right? In terms of society.
No, it's nothing new, but I guess the scale at which it's happening, I don't know. Maybe that's what feels different. I don't know. Maybe. Mm.
I tried to pitch Microsoft with a LMS structure, but then what their outcome is that, hey, we don't pay outside the organization for anything, but we will still take your idea. So said Google.
And maybe you have to write it yourself and push it as an independent entrepreneur then, Courtney.
Yeah, I'm too old now. I have the idea, but for it to pass fast, you have to deal with
Never
Uh,
too old. Never too old.
uh,
Never too old.
But I have enough young people in the group. You can partner with them.
well, we'll see. All
I
I
know.
need is an engine, It's just the brain, an engine of a piece of software that can pick from different points based off of a schedule. Like you set a timetable, and when you click on that area on it, like a regular school timetable, and you click in that area, whatever subject, whatever topic you have on hand, it distributes it at that time, whether it be online or pre-recorded set lessons.
Okay. Yeah, so you and some of your classmates can talk and max out that. All right, so let's formally go through this quickly so that those who have not yet watched the recording and configure their machines can do so. So we have started looking at programming, and we have looked at programming using Python. We have been using the Jupyter Notebook as our interface or our editor. And at this point, persons should have a basic understanding of the process that they need to follow when they are writing programs. So what is a program? Well, it's a set of instructions, and the instructions are supposed to enable the computer to carry out specific tasks. So that's what a program is. Now, you'll also find that it's important to understand what we call the syntax and the semantics of the language, because you will be using a language to write these commands. Every language is different, meaning every programming language comes with its own syntax. Syntax means rules. These are the rules that you have to use to formulate valid commands within the language. So part of the syntax will also cover the vocabulary of the language. In other words, what are the commands which are available? But the rules or the syntax will also govern how do you put these vocabulary elements together so that you end up with a phrase, programming phrase that makes sense. So that's what a program is. Now, when we talk about programs, what I have just discussed is actually what we call source code. So these are the instructions which are written by the programs, and typically for the kind of programs that we write today, these are going to be human readable. Once upon a time, it was never that human readable because we used to write in machine language, which is ones and zeros, or we used to write in assembly language, which is a more terse vocabulary or a more compressed vocabulary for getting things done. Not as nice and easy to read and understand as Python is. But that's the source code. Then we spoke a little bit earlier about algorithms or pseudocode. So your algorithm or your pseudocode are just the steps that you use to solve a problem. If you understand this step, which you must take to solve the problem, then the next step is to appreciate the syntax of the language, the vocabulary, so that you can now construct something that the machine can understand and execute. And the point I'm making here is that algorithms and pseudocodes are not executable. They are not executable because the computer does not understand them. And that's why I mentioned earlier, it's really a stepping stone. It is for you, the programmer, so that you can elucidate your thinking by virtue of using these algorithm tools or these flowcharts. It allows you to make your thinking visible. And then once your thinking is visible, your thought process is visible, then the next step is that you must now take that and go and write code. If it is that you understand, then it makes no sense to sit down and write algorithm, because what you end up doing is wasting your valuable. Yeah. So you only use the algorithm process whenever you realize that you have like logical errors. And so what you do is to now use the algorithms to make your thinking visible so that you can identify or debug what is happening, identify the problem, so that you can then make the modifications to your source code so that the program can work properly. Now, the other thing that is important is input and output. And we have looked at both as we have journeyed through the language thus far. So we have looked at the input function or the input statement that allows us to enter data into the computer program. And we have looked at the print statement as the primary way for us to generate output. There's another way in which we generate output, which we call files. We're not going to talk about databases in this module, but we'll talk about files. And so we can also send output files. And the files will give us that permanent storage, which is similar to that of a database. Then we also have to talk about the execution flow. So it's important for us to structure the commands in an organized way. And the analogy for this is whenever you get up, there are certain things you do as you get ready for work. So I assume that before you leave the house, you have a bath, you clean your teeth. And I assume that those are done somewhere towards the tail end of the process from your wake up. So you might wake up, you might wash your face, rinse out your mouth, prepare your breakfast, get your clothes ready, have the breakfast, then at the tail end, then you clean your teeth, you shower, you get dressed, you leave. And it might be counter-intuitive for you to reshuffle some of those things. It might be counterproductive for you based on your workflow. In a similar manner, we are saying that within a program, the order in which we do things, they do matter. And the execution flow allows us to determine. Now, we have looked at two broad categories of execution flow thus far. We have looked at the one that deals with sequence, meaning the first command that you see is the first command that you execute. The second command you see is the second command you execute. And that is the default method of execution flow within the programming language. But we have also looked at selection, where we can have a choice. So we have looked at the if statement, the if else statement, and the if else if statement as a way in which we can determine when particular instructions are to be carried out. And that is a part of execution flow. The third one we have not looked at as yet. We should be looking at that by about Thursday. And this is about loops. Matter of fact, loops are discussed inside this same document that I have here. So loops are just a way for us to repeat stuff because sometimes we're going to find that it is prudent in order to solve a problem for us to be repeating the same set of commands over and over until we reach a termination point. For example, we might want to process a set of students and calculate their GPA. So we would keep on getting a new student, get the data for the student, which would include the grades, and then we compute the GPA. And having done that, we move to the next student and perform the same set of operations over. And we would keep on doing this until there are no more students to process. So that would involve a loop. All right, let me pause here just to get some feedback from you in terms of how well you're appreciating what has been presented.
Ouch.
All right, so I'm not hearing any dissenting voice as to persons having a challenge. So let's continue. So there are different type of categories for software or for programs. We can have system software for operating system. We can have utility software like antivirus software. And by and large, the greater portion of software will fall into the application category, which are pretty much the type of programs that we are writing. These are the programs that will provide some sort of business value to organizations. Now, I had mentioned at the outset that there are a few elements that you need to appreciate if you are going to be good at writing programs. And I've just listed the key ones here. Syntax, we've spoken about that before, the rules. Semantics, spoken about that before, the meanings of these commands that we write. We've spoken about variables, which are the storage location for the values. We've spoken about data types, the type of data that can be stored like integers or strings, etc. We have spoken about operators, which are the symbols that we use to represent mathematical computations like the plus sign or the exponentiation sign. We have spoken about control structures. Control structures are those execution flows that we mentioned earlier, such as sequence and selection and loops. So all we need to do here is to just look at loops to round out the trifecta, the sequence, the selection, and the repetition. We've also looked at I/O, input, output, so that's 9 in terms of our input statement and our print statement. What we have not looked at as yet are functions and procedures. We will look at how we can create our own contained segments of reusable code. So some of those programs that we have or examples that we have done already, we can functionalize them, put them or package them into functions so that we don't have to reinvent the wheel each time we need the same kind of functionality or task to be performed. You're also going to find that we're going to make use of some libraries. And libraries are really prepackaged codes, prepackaged functionality that we can make use of. Matter of fact, we have been making use of libraries and functions already. The input statement that you have been exposed to is found in a library. And that input statement is actually a function. And because it already exists, you don't have to write your own input command from scratch. The print statement is also an example of a function, and you have been using it. And because of that, you don't have to rewrite your own print statement from scratch. So this is the benefit of making use of libraries and functions. Another thing that we're going to talk about is the whole concept of error handling. So as we write code, there are going to be times when abnormalities within the code is going to manifest itself. For example, we're trying to read from a file, but the file is not present at that location. So because the file is not present, then we cannot read from the file. And this is going to be seen or flagged as an abnormal condition. And so we need to know, how do we handle these abnormalities? And the mechanism for doing this is known as error handling. So that's something that we'll also be looking at
Is
as
that what
we
they,
proceed. I didn't get that.
is that what they call garbage collection?
No, garbage
No?
collection
Oh,
is another thing.
oh.
So garbage collection is what the machine does for you internally. So you really don't handle that. So a variable has a scope. You create it, and at some point it dies. When it dies, the system needs to free up that memory. If it does not free up the memory, then you might realize that you can run out of RAM. You know that RAM is very valuable, right? So whenever the variables are no longer being used, then it's going to be prudent to get rid of it and free up that space. That's what garbage collection does. So it's a different concept. Now, as you sojourn within the programming field, you will find that first we talk about a compiler or an interpreter or an assembler. And so you just need to have a basic understanding of what is meant by these terms. And I think the easiest way of understanding it is to say that all of them facilitate translation of your source code to machine code, which leads us to an interesting concept because your computer does not understand anything if it's not expressed in terms of binary. So we're talking about ones and zeros. That's all a computer understands. So even though we are writing these programs in these high-level languages which are human readable, so we can read it and understand, for the computer to understand all of that, it has to be converted into machine language. And that is the purpose of compilers, interpreters, and assemblers. So you might say, well, if they all do the same thing, then why do they have different names? And they have different names to differentiate between how things get done. So for a compiler or a program that uses a compiler, you have to convert all of the code that you write before you can execute anything. So you compile everything first, or you translate everything first before execution begins. That's a compiler. An interpreter works differently. It converts and executes line by line, which means that theoretically, if you are using a language that has an interpreter and you have 20 lines of code, but you have a syntax error in line 19, Then with an interpreter, it can go ahead and execute lines 1 to 18. And when it reaches line 19, then it signals that you have an error. With a compiler, if line 19 is incorrect, then the program will not execute at all. Because everything, first of all, has to be syntactically accurate before execution can begin for a compiler. And now an assembler is what was used, or maybe I should say it this way. An assembler is a compiler that was used in the early days so that we could convert from assembly language into machine code. So there was a language known as assembly language, which was more low level. And I mentioned earlier that the commands were terse. They were compact commands. So for add, for example, you might say something like ADD, and that would mean add. And for something like setting up a loop, you'd use a command like JMP, which means jump. So you're going to jump back up to a particular label. So those terse or compacted codes would now have to be converted into machine language. And back in those days, they call it an assembler because you're converting from assembly language
Oh, that's
to
when we used to use
machine
go to.
language.
We used to use go to
No,
and
you
use
know,
that. Go to still use.
Was actually used as a high level thing inside things like basic, quick basic.
Yeah, basic. True.
Go to. What is go
Yeah.
to?
It's similar to a
It goes,
JMP or a jump.
yeah, yeah, it goes along with if that don't happen, then you go to previous or whichever it directed to.
It was like an if statement.
No, it's like a loop. So
Oh,
you
it's what?
jump to a previous point in a program or jump to
Oh,
a later point in a program.
okay, I get it. Pre-
Yeah.
Works
Previous
But
with
that not
point.
really
conditional
but that,
statement.
but that not really important for the price of rice, no.
Oh, I,
So I know when I get sidetracked by that. We're just giving you a historical view of what preceded where you are now. All right, so I have just spoken about the compiler, interpreter, and the assembler. You have the reading here, so I won't waste time going through all of this, which carries us to this page. Now, this is nothing that you don't know. We have done this by writing programs. You have created variables. You know that variables can hold different types of data. You know that as the program executes, we can update the value inside of the variable. You know how to create a variable in Python. We haven't looked at all of this. So this is nothing new. The only thing that I'd like to mention here is within some languages, there's the concept of a constant. For example, in the C language, C++ language. And a constant different from a variable in that once you create a constant, you do not change the
Doesn't
value for the
change.
execution of the program. So for example, let's say that our
concept.
tax, for example, the tax rate, like income tax rate, we might want to say at the start of the program, let's put that inside of a constant because we are assuming that this is not something that will change often. Another example that we could use for constant is like pi, 3.14. We know that that is what pi is, so we could put a value like that inside of a constant because we are saying that we don't expect it to change as we traverse the program. Which carries us to IO operations, which once again, right? So input, output, we have looked at the input statement. We have spoken about the nuance of the input statement in that what is entered is always stored as a string, and that if you want to use it in a numerical context, then you have to do some sort of conversion. So, I mean, you know this by experience. We've also looked at the print statement, and I have looked at the formatted or the F string, the formatted output, where we can display the content of variables along with supporting text. All right. So everything that we have looked at already, you know. Now this is something new. We had spoken earlier in this class about the fact that we can store things inside of a file. So a file is really just going to be some component that is going to be stored on your hard drive that allow you to make your data persistent. And persistent simply means when you turn off the machine, you don't want this data to be lost. So in other words, you want to take the data from RAM and put it on your hard drive. And we can do that by creating a file. And here we go with a quick example on how to do that. The command is with, and then we use the open command. Inside the open command, we are going to put the name of the file that we want to open. So in this case, the name of the file is example.txt. So we know that we are opening a text file. And we are opening it using the read mode, which means we want to open this file and read the content of the file. Now, we need to give this file a name. This is now an internal name that the program will understand. So this is the external name, example.txt, which resides on your hard drive. And this is the internal file, which is going to be used in your program. So in other words, you're creating a mapping between an internal name and an external file. Once you have done that, you put a colon, that's part of the syntax, and then you're going to indent the codes that you want to execute as you process the file. And in this case, we're using file.read, which allows us to read the file. And then having read the file, we put it in some variable. And then we can simply display the content of all of the variables. And now there is a distinction because we can have two types of read. We can have a read which get the entire content, or we can have a read line which gives us a single line. Going back to the GPA example that I had mentioned earlier, if we had a file that having student and their student grades on one line, and we want to compute GPA, then it would be more prudent for us to use read line so that we get a student with all of the data, then we compute the GPA, and then we move on to the next student. So it is in cases like those where we are going to use read line over read. All right, so that's opening the file and reading.
So you say open the file, but it say open and in quotes the example that text. Is it that you give it a location where it says C drive or D drive or whatever? The actual location.
All right, so usually we assume that the file is within the current folder. So I've asked you to set up Visual Studio Code. When we start working with it, you realize that we'll be creating folders to organize our project. And it is recommended that the file that you're going to read will be in the current folder that has the program. That being said, if it is that it is stored somewhere else outside of that container, then yes, you can indicate the location, the file path, by specifying the drive and the list of folders that you must navigate in order to reach the file. But just to say doing that is a bad practice because you want your program to be self-contained within a project. And if it's self-contained within a project, then it means that your program will be looking at your current directory and pulling the file from it. So there would be no need to spare the drive.
Understood.
Yeah, man, respect. Now, if we can open a file, then we must can write to a file. And the syntax is similar. With open, we indicate the file. But note that the file mode is now different. Instead of R, we now have W, which means that we are rewriting to the file, sorry. So the mode is now different. Now we can write. We can write or we can append. And the distinction between the two is that if you write, then all the data that you had previously gone. So I would say use W sparingly. The other mode is A, meaning append, which means it's just going to add the new data to the end of the old data. Now there's something known as RB, and B simply means binary. So if it is that you want to write it in binary mode, then you can use RB. For example, if you're reading like an image file, then I mean that's not a text file. So you'll be reading just the bits and then using some sort of tool to convert those and make sense out of those bits, those binary digits. So in that case, we could be using RB, etc. Um, for our purposes, though, we are going to be working with text files. So I've just put this here for completeness. All right. We spoke about exception. Well, maybe I should do a check now to see who is following and who is lost. So let me pause a minute so that you can clarify anything I've covered or get found.
Now open the image and resize it.
Yeah, man, you can do several things with the image as long as they have the appropriate. All right, so I guess everybody is good. I'm not hearing anybody complaining. So we are now on to exception hand. Now, let me pause here. It's not enough to just me go through this. You must take these codes and experiment with them on your own so that you get a deeper understanding of what is happening. You're going to hear me go through it and you're going to say, yeah, man, I understand what sir said. And I don't doubt that you understand as I'm saying it. But until you experience it for yourself, you don't understand it fully. It's just like swimming. You see somebody do it and you say, yeah, man, me know what to do. Just move your hands on, you move your foot and you turn your head so you take in air and yeah. But until you go into the water and try do all of that in a coordinated way, then you really don't know how to swim. All right. So looking at exception handling. Remember I said that exceptions, well, no, I never call it exceptions. We look at error handling or mention error handling. I remember I had said that when we talk about error handling, we are saying that invariably as we write program, some abnormalities may end up. For example, we're trying to read a file that does not exist. That's an abnormal condition. Or we're doing a division and we're trying to divide by zero. Now, as you know, you can't divide by zero. So if you put it on a calculator and give you E, clearly that's an error. So that's another example of an abnormal condition. So modern languages provide us with a mechanism whereby we can wrap codes that might have these errors inside of some structure so that in case the bad thing happens, then the program don't just shut down or don't give some cryptic message that the user don't understand. What you are allowed to do is to track that error and exit the system in a graceful manner so that the users are not unduly shaken. Because sometimes when users are doing things, especially when I'm working with multi-million dollar applications or them doing critical things, when the errors pop up and the errors look cryptic, then them start to have heart failure and stuff like that. In terms of user experience, we don't want the users to be going through that. So we want to give them some reassurance when things go wrong to indicate that, listen, we got you covered. And that is the reason why we have these mechanisms within the programming languages.
So
Yeah,
Christine is asking if you could let her in, please.
just give me a second. Yeah, I remember that you have to keep me updated with all of these things, all right? Because as I mentioned, I'm not using my normal full screen configuration. Thanks
So
for that.
these are built-in handlers, sir.
Yeah, man. So the exception handlers are
Right,
built-in commands
right.
we
Before we
can make
use
use
we
of.
used to dedicate the errors. So if it didn't find the file, then it would display an error or give you an option what is next.
Yeah, so this is a more streamlined way of doing that. So the key thing here is the keyword called try. This signals that you are putting in your error handling in place. And the code that you want to wrap is going to be indented underneath the try. So if you realize here, we're trying to open a file, and after we open the file, we're trying to read the data. So those are the two lines that we're associating with the try command. But we're also saying that an error could occur, meaning we probably can't find the file or the file is corrupt. So because of that, we have what we call except, the except block. And this tells us what to do whenever an exception or an abnormality has occurred. And in this case, we're saying that the kind of exception that we are looking for is the exception that is called the file not found error. And I know that I'm looking for that exception because I am trying to open a file. And I know that it is possible that when you open a file, the file cannot be found. I also know, and this is by doing the research, that there is an exception that map back to that called file not found error. And so because of that, I'm making use of that keyword. Now, where do I put my message? I'm going to put my message inside some print statement. And instead of the system generating its own message and giving to the user, I can now give something that is more useful to the user. For example, I can indicate the name of the specific file that was not found. So I could have easily have said non-existent.txt file was not found. Or I could say the file you are looking for is not in this current location. Whatever kind of message I think will make more sense to the user so that they don't freak out. So this is the whole concept of exception handling. It's key to remember that we need to have our try block where we are going to put the code that we want to test for exception. And we need to have our except block, which is where we handle the abnormalities when they occur. So moving on, we talk about TXT files, but there are other files that we might want to work with. For example, CSV files, comma separated value files. So these are going to be those files that you can create in Excel where your data values are separated by commas. And instead of using a text file, then I might want to use a comma separated file for doing things like processing the student's GPA, as I had mentioned earlier. Because it would just make sense, right? I mean, we'd have the commas would separate the name from the data values from the grades that that student receives. Now, why it would be better to use a CSV file than a text file for this case is that when we talk about a student name, typically they have a first name and a last name. And we typically separate first name and last name with a space. When we have the CSV file, we will be separating first name and last name with commas. So it will be clearer to see that we're talking about two different values instead of viewing name as being one value. So it makes life easier when we have what we call a delimited file. And by delimited, we mean we're storing the data and we're separating the data with some sort of symbol. In this case, the delimiter is a comma. So the point here is that we can operate with the CSV files. And we can operate with the CSV files by, first of all, using a library. So the library here is called the CSV library that we can import. So it's not there by default, but we can include it, import it. And once we do that, then we now can get access to the functionality that will read a CSV file, which in this case, I'm not sure where my mouse cursor went, but which in this case is going to be this thing here. So notice it's called CSV, the same thing that we had used earlier, imported. And from CSV, we're using the reader operation. And this reader will read some sort of file. What kind of file? Is going to be this data.csv file. So we're opening the data.csv file. We're opening it in read mode. And then we are going to be using the CSV.reader to allow us to read the content of the file. And then the line below that simply now allows us to go through this content line by line and display it. So this is a loop for row in reader. We'll talk about loop later as we go further into the document. But just to say here, this is a loop, which means we are reading through the content of the CSV file. We are getting a row, and each time we get a row, we print the row onto the screen. So this just summarizes the I/O operations that we have touched on earlier, input and output. So input and the print statement. Then we talk about opening a file for read and write operation, opening a file for append operation, and opening binary files. Then we'll also look at CSV processing by making use of the CSV library. So that is something new. So exception handling and file handling is something new that we're adding to the table. As I would have mentioned earlier, it is important that you go through and that you practice so that all of this concept becomes, second nature to you. All right, so moving on, Python has some arithmetic operators, which you already know, plus and minus, and multiplication and division, different types of divisions, exponentiation. I also show you how you can use the exponentiation operator to compute the root of a number. So this is the cube root, 1 divided by 3, but use the exponential sign, which means if you want the square root, you use the exponentiation sign and 1 over 2 because it's called root 2. So, you know all of that. We've also spoken about comparative operators. So we have looked at how to check for equality, how to check for greater than and less than. The symbol here means not equal to. So it's an exclamation mark followed by the equal sign. It means not equal to. And we can have less than or equal to, and we can have greater than or equal to. So I mean, most of these stuff we covered already. So as you go through the document, it should be clear. Most of these things, it should just jump out at you and easily you understand what is happening. So let's talk a little bit about the logical operators that you're going to find in Python. And there are three. We have the AND operator, the OR operator, and the NOT operator. And the examples here are pretty straightforward to allow you to understand. So what AND does, it allows us to test two conditions. And a condition is any statement that you can test to see whether or not it's true or it's false. Typically, you'll find that these statements will have some comparative operator in between them. So First statement here. It's asking a question, is 5 greater than 2? And the answer to that is what? Type in the chat. Is 5 greater than 2? What's the answer? Yeah, so it is true. I know that the other question asks, is 10 less than 20? Type T if true, F if false. So that's also true. So we have two conditions that we're testing. Two of them happens to be true. So if we join them with an and, then the output is true because both conditions are true. However, if at least one of these conditions is false and you and them, then your output is going to be false. So let me put it another way. When you and things together, the output is only true if all of the conditions are true. If at least one condition is false, then it means that the entire thing that you have ANDed is going to be false. So that's how the AND works. And if you did do basic electronics or computer maths or anything, well, basic electronics, you hear about the AND gate and the OR gate. So the AND gate, this is how it's operating. If both inputs are true, then your output is true. But if at least one of your inputs is false, then your output becomes false.
Well, they have not yet to
Yeah,
electronics.
man. You have not gate too. You have AND gate, OR gate, not gate. You have NAND gate, exclusive OR. Yeah, me know a little bit about electronics too. But let us continue. So the OR, how does it work? Well, as long as one condition is true, then the entire thing is true. So you only need one to be true for the entire thing to be true. For example, you you want to go to a football match, and I'm saying if you're 18 or you can pay for the ticket, then you can go to the match. So my question now to you is, suppose a 5-year-old can pay for the ticket, will they go to the match? Will you allow them into the match?
No, according to this.
And the answer is yes, you
Mm-hmm.
should,
Right.
because it's an or.
So wait, or go again?
So or says, as long as one condition is true, the entire thing is true. And listen what I said. I said, if the person is over 18 or the person can pay for the ticket, let them into the venue. Let them watch the match. So in that case, even though I have said that the age should be 18, I've also said, well, if them can afford the ticket, let them in. So a 5-year-old who can afford the ticket, you'd have to let them into the venue because that's how the or works. If it was an and, then that 5-year-old could not enter because you'd be saying you have to be over 18 and at the same time you have to can afford the ticket. So if you're a 5 and you can afford the ticket, you wouldn't be able to go in. But if you're 25 and you cannot afford the ticket, you would not be able to go in either because you would have to meet both conditions if it was an and. If it's an or, you can just meet one condition. I hope that kind of clarifies. And you will get, some practice questions, etc., that will allow you to, grapple with the and grapple with the or. No, not. What does not do? Not just reverses the truth value. So if the thing was false and you said not, then it means that the thing becomes true. And if the thing was true and you said not, then it means that the thing becomes false. So looking at this example, is 5 greater than 2? When you tell me this already up above, when you say yes, this is true. Well, if I say not 5 greater than 2, then it means that the output is now going to be false because this is true. And I say not true. Not true is false. Because if it's not true, then it must be false. So that is the kind of thinking that you have to be grappling with. All right. Now, just to say that whenever we have multiple operators that we're using together, then there's a rule known as the BOMDAS rule that we make use of. It simply means bracket first, then you look at your orders of magnitude. So we're talking about things like your exponents and your roots. And then we're saying that multiplication and division move from left to right. And it is greater than addition and subtraction, which also move from left to right. What that means? It simply means if you have some addition and some multiplication within your statement, you will do the multiplication before you do the addition based on the BOMDAS rules. Because multiplication and division must be done before addition and subtraction. The only time that changes is when the operations are inside the brackets. So anything inside of the brackets, you do first. So if we look at this example here, the first thing that we're going to do is whatever is in the brackets, wherever the brackets appear. And if there's more than one brackets, then we'll process them from left to right because we read from left to right. In this case, there's only one bracket, so 5 plus 3, that is 8. So we have 8 times 2 minus 4 divided by 2. And then the next thing that it tells you is that, well, you're going to do the division and multiplication, but you're moving from left to right. So you're going to have 8 times 2, which is 16. And then you're going to have 4 divided by 2, which is 2. So then you have 16 minus 2. And then you say, all right, 16 minus 2, what that give me? Give me 14. So the point I'm making here is that the syntax of the language has to be precise so that there is no ambiguity in terms of how things get done or computed. And so they make use of the BOMDAS rule so that we can ensure that that does not happen. All right, so time to check in, how we stay. Are there any concerns? Anybody lost? Now is the time.
No, sir, except the one before you get 14.0 and there's no marker to say display decimal.
Which one?
Okay, that's not mine. Don't worry about it. We get 14. So that mine. All right, so all clear. I'm following.
But I think with Python though, isn't it that you'd have to declare the variable either, let's say a Boolean variable or a string? Well, if string is text, but Boolean is number, right? Wouldn't you have to declare the variable before it decides how it's going to do the output?
No, Boolean is not a number. Boolean is true or false.
True or false? Okay.
Yeah. But the point you're making is what now? What's the point?
The decimal, how the decimal come in place.
Yeah,
Wouldn't
I'm saying
it,
1 minute. Hold on. No, don't worry about the decimal. The decimal is not the the major issue here. The issue here is that you understand the BAMDAS rule. If you understand the BAMDAS rule, whether or not this is 14.0 or just straight 14 is neither here nor there to me. The key here is the BAMDAS rule. So good?
Got it, got it.
All right, cool. All right, so moving ahead then. Let me see how far I am in this document. So finish. All right, so string operators in Python. So the point that we're making here is that we can add strings. And if we add strings or join the strings, that is known as concatenation. So we're adding hello to a space to word, and then we get hello space word. We can also multiply a string in Python. Yeah, so that's possible. So Python times 3 means we want to say Python being repeated 3 times. We can also check for membership using the in statement. So we can say if the thing is in the text. For example, is the word love in text? Text being I love programming. And the answer is true because love is found inside that big text. Is Java not in text? Once again, the output is true because when you look at the text, I love programming, you don't say any Java. So it is true that Java is not in the text. So you say true again.
One of the conditions is true
Say it again.
because one of the conditions is true.
When it's a one of the conditions, what you mean?
I love programming, so the word love text is there, and then Java is not there.
Correct. But you realize that in both cases, the question that is asked is true, right?
Yeah. Mhm.
Okay, cool. Cool. All right, we can also compare strings. When we compare strings, though, please note that the case matters. The case matters. All right. So capital A is not the same as common A. Matter of fact, I'm going to give you an assignment. I'm giving it to you now. I want you to find an ASCII chart. ASCII, ASCII. I want you to find an ASCII chart, ASCII table. And I want you to look at the letters in the alphabet and see the values that are associated with them. So, for example, look at capital A, look at common A, and tell me if the values, the numerical representation is the same. And do it for several other things. And I think you'll kind of see the pattern. Also, I want you to have a look at the numbers, and I want you to see where the capital letters start and end in terms of the numbers associated with it. And I want you to look where the capital, the common A and Z, where those numbers begin and end. I want you to look at it, compare it, and then I want you to come back to this part of the paper and figure out why these outputs are being obtained. In other words, why is apple greater than banana? And that give you false. And why is apple less than banana? And that give you true. So why these statements, though they look similar, one give you false and one give you true. So that is your homework. You're going to get the ASCII table, appreciate the numbers which are associated with each letter of the alphabet, whether it is uppercase or lowercase. And then you come back here and you appreciate what is happening right there. All right, so indexing. There is something in Python known as a list. And whenever we talk about a list, we represent a list using square brackets. Now, a string, by definition, it is a list. It is a list of characters. Even though we might not say that explicitly, I mean, it is. So, apple, it is a collection of characters, APPLE. So, what indexing does is it allows us to target a specific character based on its position within the string. So we're looking at this word, for example, Python. And if I ask you to give me the letter at index 0, then I'm telling you to give me the letter at the beginning of the word. So index 0 always means beginning of the word, which means that index 1 is always going to mean the second letter within the word.
It says
Now, if you
-1.
no, if you put a negative before it, so if you have a negative index, then it means that you're starting at the end of the word. So -1 correlates to n, which means that if you had put -2, then you would have been targeting the O because you're now moving from the back of the word. So if you're moving forward, you start at 0. If you're moving backward, you start at -1 going down. So that's indexing. How can you get a particular character from the string? Now you also have slicing. And slicing is where we want to cut out a substring or a portion of the string. So we can indicate the start and the end. So for example, the entire string is hello, comma, world. But I want to get the phrase that begin at 0 and end at 5. So 0 is H, then 1, 2, 3, 4. Now, we're not going to go to 5 because when we talk about loops, we're going to realize that we go to 1 before the end. And this is what really happening here is we're really looping through this string. So it means that we're going to end up with 0, 1, 2, 3, 4, which actually works out to be 5 characters. So we're not going to pick up the comma. We just end up having hello as our output.
Sir, let in another.
All right, cool, thanks. Yeah. So that is slicing. Now, remember also we talk about the whole negative thing, right? So -6, that is where we would start. And notice that we don't have an ending. So we have the colon, but there's nothing after the colon. So it means that we start at wherever -6 would put us, and we want to go to the end of the string. So we end up with world with the colon. So that's slicing. It just allows us to take out any portion of the string that we want. Whereas indexing allows us to take out any character out of the string that we want. All right, you're going to come across the concept of a data structure. And a data structure is really an organized collection of data. So I spoke about a list earlier, and you'll find that we will be using list a lot because it allows us to store things in an efficient manner. For example, I can have a list of fruits. Remember, I said that a list has square brackets. So inside this list, I have apple, banana, and cherry. Those are all string values, and they are separated by commas. So this list is called fruits. But I could also have a list called numbers. And these numbers, for example, could represent the grades that were obtained by a particular student. So for one test, them get 10, for the next one, 20, etc. So we say that lists are convenient structures that we can make use of to store data within our applications or programs. Now, this is us that we can access the elements in the list by using indexing or slicing. In this case, though, the zero position would relate to a string. For example, this is a list with three string elements. So if I talk about the zero position or the zero index, then it means I'm talking about apple because that is the first. Because that would be the first item. So apple would be 0, banana would be 1, cherry would be 3. What did I just say? Cherry would be 2. So 0, 1, 2. Cherry would be 2. So if I said fruits, square bracket, and a 2 inside of it, then I would be displaying cherry. All right, so just bear in mind that the indexing and the slicing work the same way as up above. It's just that now we're treating each item that is separated by the comma as being a single unit of value. So we can add elements to list. That's all this is saying here. A list is mutable. It can change. So we can add elements, we can remove elements, we can update elements. So that's all that we're doing here in this section, just to illustrate that that can be done. And in the section that follows, we are showing you that we can have what we call nested lists, list within list. So in this is a matrix, for example. So it is 3 rows, 3 columns. First row, second row, third row. So at the top we would have 1, 2, 3. Below that we have 4, 5, 6. Below that we have 7, 8, 9. So it's really a 3 by 3 matrix. So we could actually use a list to represent like a tic-tac-toe game where we have a 3 by 3 matrix, right? Matter of fact, that sounds like something that is interesting enough for me to allow you to do, maybe as a project, to design a tic-tac-toe game in Python. So let me go and think about that some more. But it sounds like, yeah, that's the way we want to go. All right, and this is where I'm going to stop for the night. Dictionary, because I think that we have covered a chunk of things that we're not going to need to go back over and actually practice these stuff. So I stop at a dictionary. So I have a list, we have dictionary. So a dictionary is what we call a collection of key value pairs. And it makes sense when you understand what I mean by a key and a value. So a key is like a field name or a tag. And the value is going to be that thing that is associated with the tag. For example, age is going to be the key. 25 is going to be the value. So I know that the age of this person is 25. I know that the name of this person is Alice. I know that the city that this person is associated with is New York. So city, age, name, those are the keys. Alice 25, New York, those are the values. And a dictionary, you put it inside these curly brackets. So similar to our list is placed inside square brackets, please note that a dictionary is placed inside curly brackets. And just like how we can manipulate a list, we can also manipulate a dictionary. So we can print the content of a key by using the name of the dictionary, square bracket, and then in double quotes, we put the key. So the key here is name. So in other words, go to the dictionary called person, look at the name key, and give me the value. Well, what's the value? The value is Alice. We can go back up here and check it. Person is the name of the dictionary. I want the name key. What is associated with the name key? It is the value Alice. So I'm saying that you can get access to the values within a dictionary. You can modify the dictionary, meaning you can add new keys to the dictionary, or you can update the value associated with a key in the dictionary, or you can simply remove a key from the dictionary. So those are things that you can do. And we're just pointing out here that just like we can have a nested list, you can also have a nested dictionary. So notice students is a dictionary, but inside a student, we have Alice and we have Bob, which are keys. But Alice is also associated with a dictionary where we're storing the age of Alice and Alice's grade. She got an A, bright girl. We're also storing the age for Bob, who is 22, and he happened to get a B. And just to round out things, notice that we're now treating this almost like a two-dimensional structure because uh, we have a dictionary within a dictionary. So the top dictionary is students. So students. But we want to get the Alice key from out of students. So we have Alice here. But we want to get the grade key from out of Alice. Well, here is the grade key. So this is actually saying, I want the grade for the student, Alice. Well, what is the grade for the student, Alice? It's A. We can look right here and see that for ourselves as we look within the structure itself. You can see. And this is where I terminate for the night. Are there any questions, clarifications which are needed, etc.?
Indication of the types of brackets used.
What do you mean by the type of brackets? You mean these?
Right, you have those, but in the other spectrum, you use a square bracket.
Yeah, man. So for
Curly
lists,
bracket.
you use square brackets. For
Right, so
dictionaries, you use curly brackets.
right. But in the output, you use some square one with regular bracket.
No, man. So don't confuse the structure with how you access the structure. So to set up the structure for a dictionary, you use curly brackets.
Right, but look
That's
at the
part of the
prince.
syntax. Yeah, man, but follow me now. That is the syntax.
Right.
To set up a list, you use square bracket. But to access components of a list or to access components of a dictionary, you specify the elements within the square brackets. For a dictionary, what goes in the square brackets is the key value, is the keys. Well, not the key values, is the keys. But for the list, what goes in the square bracket is the index number, the index that you're trying to access. So there's a distinction between setting up a list versus accessing the components of the list. And there's
Right.
also a difference between setting up the structure for a dictionary and accessing the elements of the dictionary.
Quite so.
Yeah, man, no problem. Any others? All right, so that's us then for the night, folks. You know what to do. Those who don't configure them system yet for VS Code, you need to configure your system for VS Code. You're also going to need to go back over this recording when it is made available. Please remember that I'm posting it on YouTube. You have the YouTube playlist right there on your portal that you can go and access it. All right, so I'm posting them on YouTube.
So far, it's 2 video up there.
Yeah, man. So far, we have 2 videos. And remember, you also have the homework about the ASCII table. To find an ASCII table and look at the letters, see what are the numbers associated with them, and then you go back to that section in this document and record your observation.
Greater values for the comma and
I don't want you to tell me
the
anything, no, brother. I want you to go look it up, brother. Don't want you to tell
I
me
already
nothing.
did.
All right, I don't want you to tell me nothing. No, make the
But
other
I
people go,
answered
go
it
do
in the
them
chat
work.
already. But I answered in
Yeah.
the chat. Yeah. The capital and the common.
Who put things in that chat?
Mm.
You?
Yeah. That's the
So,
money first.
I forgot take off some marks off on the first test then, man.
Why
So
why why
you
Mr. Scarlett I move like him crucial, so?
But wait,
so
why
you
me I
are
lose marks?
so you and Courtney take off some marks off on the first test.
We there because we excited, brother. So we jump the gun. We wish it could have done today.
All right, boss. I give the other people. I will give the other people a little chance to do it for themselves. All right.
Okay, so I'll try to find some time and key in these values and see how them function to my
Yeah, man. Most
understanding.
definitely. Most definitely. So, all right then, ladies and gentlemen. So, see you on Thursday. Take care of yourself. Bless up.
Okay, sir.
Yeah, man. Guidance.